Hello दोस्तों, in today's session we learn about the difference between uniform distribution and the triangular distribution. Okay, so uniform distribution is a continuous probability distribution, and as the name suggests, it is uniform. Okay, so what is uniform here? That is the probability distribution. Okay, within the given range will have equal chance of occurring. Okay, so it will be having the equal chance of probability, equal chance of probability. So for example, if you roll a pair die, okay, if you roll a pair die, then each number on the die, that means you are having 1 2 1 2 3 4 5 6. Okay, so on in a die you are having 6 number, right? Okay, so each of the number is having the probability of 1 by 6, right? So that's the example, and the PDF of this one will be that f of x will be 1 upon b minus a, and b minus a, in this the b is the maximum value, a is the minimum value. Okay, that range. Okay, and if you draw this uniform distribution, then it will be in this format. Okay, fine, and in between this is the mean value. If it is symmetric, if it is asymmetric, mean can be anywhere. So in here the mean symmetricity is actually dependent on the range of the interval. So here it is a, here it is b. Sometimes you will also come across the figure like this. Okay, this is a and this is b. So this is the minimum one, this is the maximum one. So each of the die will have the number, correct? So the number goes from 1 2 3 4 5 6 like that, right? 3 4 5 6. So 1 is the minimum, 6 is the maximum, and each of these are having the probability of 1/6. Okay, so here the f of x is equal to 1 upon 6, which is b, and a is 1. Okay, so b minus a, so 6 minus 1, it will be 1 upon 5. So this one is your 1 upon 5. Okay, okay. Now what about the triangular distribution? Triangular distribution is the continuous probability distribution, and here the mode value, you are having 3 values. Okay, a b c. So if it is written that random variable, 3 random variables a b c numbers, okay, then it means there will be some value which is the minimum value, there will be some value which is the maximum number. Now there is some value which is the having the more frequency, which occurs more often than others. Suppose you are coming late to the office, typically every time it is like 5 to 6 minutes, but the maximum goes to like some days you are late by 20 minutes, and some days you are not any, you are not running any delay, you are unpunctual that time, that day. So it is a, that is 0, it is 0, it is 20 minutes if you are late maximum, and on an average you are 6 minutes late most of the time. So now this is a triangular distribution. So how we calculate this area of this? We know that the area in this rectangle becomes 1, correct? Similarly in this, the area of the triangle will be 1 only. Okay, so that is the probability of that x lying within the range of probability x lying within the range of A and B. So you write it like probability A x in this range, okay, x lying within A and B is equal to 1. So this area is denoted by this figure. This area is denoted by, yeah, correct, this figure, and also you can write it here also, okay. So that's the definition for triangular definition, that more likely values are more likely to occur in the middle of the range, okay, middle of the range. That means this value, at this value it is the highest number of occurrence, and less likely to occur are the extremes. So at these points it is very less likely, okay. And how do you arrive at these effects? That formula is this, okay. So that is the probability density function, okay. So how do you write this? So f of x is equal to 2 upon, okay, so okay, so probability for A A what was, something is happening or what? I'm not. Okay, I think it is taking some time. So meanwhile, let's look at the example. That the time it takes to drive to work, where it is more likely that the commute time falls in the middle of the range. So that means 20 to 30 minutes the commute takes place. But then in extreme cases, you are having no delay, or the time very less, 0, or you are taking the maximum time of 1 hour. So this is a triangular distribution, okay. Okay, now then the next thing is, yeah, A and B represent the minimum and maximum value of the range, and then triangular distribution, it is ABC, okay. For both distributions, the area under the PDF equals 1, okay. Here 1, here also 1. Now example we have already given that here. Let's understand one more examples. So any number between 0 to 1 is actually, any number between 0 to 1, 10 has equal probability of being generated. So number 5 has a probability of 1 by 10th being generated. Similarly for number 7 will be also having the probability 1/10. Then if you are using the triangular distribution with a minimum value of 0, maximum value of 10, and a mode, that is the most likely value of 5, then values closer to 5 have a higher probability of being generated. So the number 5 has a probability of 0.2, okay, and the number 0 to 10 has the probability of 5.05, okay. So now coming to this, here what I'm doing is, it is written as 2 times x minus a divided by b minus a times C minus A, and this is when it is lying, the x value is lying between the minimum value and the mode value. Okay, so if you are testing for this one, A, C, B, so you are looking at the value probability distribution when x value lying within A and C. Okay, likewise, if it is lying between C and B, okay, so if it is lying this way, this side, C and B, then it will be 2 times B minus x divided by B minus A times B minus C. Okay, so these are the differences between uniform distribution and triangular distribution. Okay, please go through these examples, then it will be more clear. If you have any doubts, you can ask in the comment. Thank you so much.